6. Now, this will not work because we define here explicitly that the parameters are of type int, so we cannot pass here double. And a solution to this, it may be to create another function with a different name and to define the parameters as doubles. But that does not make a lot of sense because we are doing the exact same thing, so it does not make sense to create a function with a different name. So what we can do instead is to, let's change this back to integers, is to duplicate this getMax function, and to do that you can press Ctrl D or command line on Mac. So I'm gonna press Ctrl D here. Now what I can do is change the types of the variables. So I can put here, instead of integer, I put double, and here I can put also double. Let's add a space to make things more clear. Now if I pass here, let's say 5.6 and 9.7, now you see that we have no error. So if you run this code, alright, so we get in the output 9.7, and this is correct. This is bigger than 5.6, but now it's using the second function, which is the function which has the parameters as of type double. And you can see that this function now, which is using the parameters as integers, is gray out, because the compiler can figure out what function to use by the argument types we pass here. So in this case we pass here doubles, and it knows that it has to use this function, which has the types, which has the parameters defined as type of double, right? Another way to overload a function is to, let's also press Ctrl D, is by changing the number of parameters. So I can put here, let's say also integer, also let's pass the third parameter now, and this is also going to be an integer. It's going to be called C. It's going to be of type int. Alright, now let's change this logic to an if statement. So let's delete the if expression. Let's put the curly braces. Alright, so let's change this now. So you can type it here now, if A greater than equal to B and A is greater than equal to C, then you're going to return A. So now we're using the return keyword. Else if, now we're putting here an else if B is greater than equal to A and B is greater than equal to C, then return B. Else C is gonna be the bigger value, so put here return C. Alright, let's press Ctrl Alt return B here. Right, so I need to put here the type, this way I get that error. Right now everything is okay. Oh, so from here is the problem. Right, so now if you run this code, let's change this to, let's say 5, 7 and 10. Now if you run this code, you see that the two functions above are gray out. And now it's going to use the third one, which has third parameters. Alright, so you get in the output 10, which is correct. So if you change this to test, let's say we put here 100, let's put here 3, and if you run this code, Now we get 100, and this is correct. Alright, so this is our discussion about function overloading, and you can use function overloading every time you know that you will do the same task but with different type of parameters or with a different number of parameters. Also, you may have noticed that we have an underline over the if statement. So if you hover over here, it says that the return can be lifted out of if. So if you click this, you can write it in this way, or we can keep it in the previous way. But because this is underline, that means that Kotlin recommends to use it in this way. So see you in the next video. We're going to talk about default parameters. Alright, so now it's time to look at another features that you can use with functions, and that is called default parameters. And let's first declare a function. So I'm going to declare down here at the end of our enclosing curly brace of our main fun. I'm going to call it send message. Let's put the parentheses, and inside the parentheses I'm going to define two parameters. The first is going to be called name, it's going to be of type string, and this second one is going to be called message, and it's going to be also of type string. Now let's declare the curly braces, press enter, and let's print those parameters in our console. So let's put a print line here, and inside the also while I'm typing this println, you may see that this println function is a function which is overload, referring to our previous video, because you can see that it has the same name, but it can take different types of parameters here. So it has int, this thing which is any, byte, short, char, long. So the println function that we've used throughout our videos is overloaded. This is why you can pass different types of data to it. Now let's type here println quotation marks, and inside the quotation mark we're going to type name equals $name. So now it's going to print the argument values that are going to pass to this function as parameters. Now let's call this function here. So let's type send message. Let's press Ctrl Alt L to format our code, and here I'm going to pass a name, let's say Alexa, and the message, let's say hello. Now if you run this code, you're going to see in the output the name here is going to be this argument that we type here, which is Alexa, and the message is going to be hello. So we have this. But let's say that for whatever reason the user doesn't want to send any kind of message, but we still need to use this function. What you can do then? One way is to remove this parameter all the way, but that's not good, because you still need to use this function with those two parameters, the name and the message. So let's say that if the user doesn't pass any message, we can define here what is called a default parameter. So we can assign here a default value for our parameter. So I'm going to put here just double quotation marks, or you can put some text here, but let's put just the double quotation marks, which is just an empty text. So if now I don't pass a message here, now it's still gonna work, because as a value for this parameter is gonna use the default value that we defined here. Alright, so let's run this code to see now how it works. So now I get name Alexa and message equals empty, because double quotation marks without any text is an empty text. Now if I want to pass here now the message, now I can pass here the message, and now our default value is going to be replaced with the argument value that we typed here. So now we're going to see name Alexa, message hello. Alright, you can do the same thing for the name. So here you can define, let's say the user doesn't want to to type a name, and we can define a default name, let's say user. Yes. Now let's say that I delete both arguments here, and I just have an empty function. If I run this, now it's gonna use the default values that we type here, respectively user and this empty string. So now I get name, user, and message. Now let's put back what we have. So let's put here Alexa, and let's put our message here again. Now let's run this code again. Now what we can also do is use what is called named parameters. And let's say that I want to pass a parameter only for the second let's say that I want to pass an argument type only for the second parameter that we define here, respectively for our message. So if I delete this, now let's say that I delete the argument for our name, and if I want to pass a value only for the message, let's put in the quotation mark because it's a string. Let's say I put the message hello here. Now you can see that the hint is name, so it's using the first parameter that we define here, not the second. So what we can do now to pass a value only to our second parameter, because as you can see, it's assigning this value that we typed here for this parameter. And to solve that, you can use what is called name parameters. So with name parameters, we can type an argument for our parameter irrespective of the order in which they are defined. So in our case, we have the name for defined and then the message. So to use that, you can type the name of the parameter, let's say message. Now you see that we have this p message and it's equals to a string, so that means that we need to pass some text there. And now we can pass here hello. And now this is gonna work because now we can pass a value to our parameter irrespective of the order in which they are defined here, right? So now we get name is this default user and the message is hello. And we can do the same for the second one, which is name. So I can put now here name, and I can type here let's say Alexa. And if you run this, now you get Alexa is the name and the message is hello. So with named parameters, this is how they are called, or name arguments, we can pass a value to our parameters irrespective of the order in which they are defined in the function. So in our case, name is first defined, and you saw there that when I try to use the message to assign a value only for the message, it was using the first parameter because this was the order in which they were defined. But with these named parameters, you can change. You can type an argument irrespective of the order in which they are defined, and you can put this in multiple lines to make it more clear, like this, let's say. So this is our discussion about named parameters and default parameters. But before we end our video, I should say that to the default parameters, we cannot only type literal values like we typed here some values directly. We can use variables, or you can use a function which can return a value. So I can define here a function, let's say fun send text. It's not going to have any parameters. It's going to return a string. So I'm going to define here a string as the type of return. And here we're going to type return, and let's type some text. Now we can call this function here send text, and now this value which is returned for this function send text is going to be assigned to our parameter message. So now if you run this code, let's increase this a little bit. So now if you run this code, you're going to see that now the default value for the parameter message is the return value from our send text function. So you can see now that we have okay, so let's change it here to no value. for our message. So now if you run this code, because there we have an argument passed, so let's not pass no argument. So now it's using the value that was passed as the default value for our parameter, which is this return value from this function. Now, because here we have one single line of code, we have one single expression, we just return some text to our function, we don't have multiple statements in our function, we can write this as a single expression function. And you can remove the curly brace and you can write this as a single expression body like we did in the previous video. So you can put it just equals, and you can remove the type here also. So if you run this code, now you're gonna see to the output for the parameter message some text, which is the value which is returned from this function, from the single body expression function, right? So see you in the next video. Alright, now it's time to look at the var arg keyword and how we can use the var arg keyword with functions. But first, let's declare a function below of our enclosing curly brace of our main function. So I'm gonna type here the fun keyword to declare a function. I'm gonna call it sum because it's gonna return the sum of all the parameters that we're gonna define. So I'm gonna define here some parameters. First, gonna be called a. It's gonna be of type int. Second is gonna be called b, also int. Third is gonna be called c, also an int. And the final one is gonna be called d, also an int. And this function is going to return the sum of all of those parameters. So we need to define here the return type, which is going to be an int, a whole number. And now we can put the curly braces, and here we type return a plus b plus c plus d. And this is going to return the sum of all the parameters that we define here, or the values that is going to be passed as arguments to this function. And you can write this as a single expression function if you want. So you can write this like this if you want. This will have the same effect. But I will write it with the curly braces because it will make things more clear. So let's undo this. Right, now let's call this function here sum. Let's press Ctrl Alt L to format the code, and let's pass some values here. So I'm gonna type here 5, 6, 7, and 10. Alright, if you press Shift Ctrl P on this, you're gonna see that the type of this function, let's press again, the type of this function is an int. So this function returns an integer. So it's an expression. That means that we can put this, instead of putting storing the return value in a variable, we can put this direct in a println function. So we can type here print ln, and we can put the function inside here because that function is of type int. So it's going to return the sum of all the arguments that we type there. So now if you run this code, we get 28 because 5 plus 6 plus 7 plus 10 is 28. Now, if I want to pass another parameter here, let's say that I want to pass another number here, I can't because I am limited by the number of parameters that we define here. Of course that I can define another parameter here, but what if I want to pass 10 numbers or 15 numbers or 100 numbers? In that case it will be very tedious to write all of those parameters, and to solve that we need to use what is called a var arg keyword. And a var arg keyword allows us to pass more than one parameter, actually more than one argument to our parameter. So to declare a var arg keyword, we type here var arg. So this is the keyword var arg. It stands for variable arguments. Now we need to define a name for this vararg. I'm going to call it numbers, and we also need to specify a type, what kind of values this vararg is going to store. Now this return keyword these variables here are red because they don't exist. Now if I want to, but first let's say that I want to type here another parameter. Now you see that we have no problem, so I can type here whatever number of numbers I want, and there is no problem, as you can see. Now to sum the values which are stored in these vararg numbers, we need to use something which we didn't cover yet, but we have a separate section which I show you how to, in which I explain this thing that I'm going to use now, and that is loops, because now we need to loop through our numbers and to add our numbers to a variable. So we need to use what is called a for loop. So to do that, first we declare a variable. I'm gonna call it let's say result. I'm gonna assign a value of 0. Now to use a for loop, we type for, and again I'm gonna go into more detail about this in the separate section, but now we need to use this because there's not another way to sum up the values inside the vararg numbers. And here we need to define a name for our variable, so it's going to be called number. And now we use the keyword in, and now we're referring the parameter, the vararg parameter, which is defined up, called numbers. All right. Now here you can put the curly braces, and inside the curly braces we're gonna type, here it should be numbers, result, and now we're gonna use that abbreviation, which is plus and equals, plus equals number, and now here we're gonna return the result, return result. Right, so let's explain what we have here. So first we declare a variable, we assign a value of 0 to it, so it's a type int. Next, what this for loop is doing. So this for loop is executing a line of code multiple times. So it's executing what's inside the curly braces until it finishes to loop through all these numbers which are stored in the vararg numbers. So it first assigns the first number to our number here, and it loops and it adds that number to our result. Then it does that again and again and again until it finishes, until it reaches the final number 5. And in that case, also gonna assign from our numbers the number 5 to our number, and then that number is gonna be added to our result variable. And when it finishes that looping, when it finishes that thing, it's gonna return the result. It's gonna return all the values which were been added to our result variable. So now if you print this, now you get 85, and probably this is the result of this calculation. So this is how you can use vararg numbers, vararg keyword to store more than a limited number of parameters defined by you. And another shortcut to loop through this is using a for each loop. So we can do something like this. But this time, let's say that I don't want to return something. So let's say that I delete this. And I can type here actually numbers for dot, here you put dot, for each, and here you type print ln. Again, this is a more complex subject which is going to be covered in the next videos. So here you type print ln, and we type it. All right, now let's call our sum. Let's define some numbers here. Let's say that I type here 1 4 Alright, so if you run this code, now you can see that every number in that that we defined here is printed one by one. So this number, this for each, which is also a loop, it goes through all of these numbers and it prints them one by one. And again, we're gonna look at the for loop and the for each in the next videos, but I had no other way to show you this example without using them. But if you feel confused by the for each or the for loop, don't worry, we have a separate section in which we talk about in detail about this. For now, we need to the only thing you need to know is that you can pass an indefinite number of parameters you can pass an indefinite number of arguments to our vararg numbers, because this allows us to pass an indefinite number of values. So here you see that we have 1 4 5 6 7 8 9 5 7 and 6 numbers that we have here. So this for each is going through all of them and it prints them one by one. So see you in the next video. Alright, now it's time to start our discussion about loops. But first, let's create a new project. I'm gonna call it loops. Select IntelliJ, click on next and finish. Right, a project is created. Let's delete the code inside the curly braces. Let's hide the project pane. And let's start by explaining what loops are and why you need to use them. So loops allows us to execute a piece of code multiple times without you writing down every line of code manually. So let's say that I want to print 10 numbers in the console, or 20 or 50. Instead of instead of typing that code manually line by line, which will be very tedious, you can use a loop and you can put that code in a loop, and that code in the loop, it will be executed repeatedly until a certain number is reached. So let's see how we can define a loop. To define a loop, we type here for. This is the first loop that we're going to look at, because there are other loops. So this is the for loop. We press enter. Inside the parentheses we type I. This is convention. You can put whatever name you want there. Now we put here in. This is the keyword in. And now let's say that I want to loop from 1 to 10, and to do that we type 1 dot dot, this is a range, to 1 to 10. Now I put the curly braces, and inside the curly braces I'm gonna put the code that I want to be executed 10 times. So I'm gonna type here println, and I'm gonna type the value of I at each iteration, and we can put it like this. You can type here, you can put in the quotation marks, and you can use the placeholder. You can put I. So now if you run this, so now you get I is 1, 2 until 10. So what it's doing is looping through this range until it reaches 10, then it stops. Now you can write this I like I did it here using a placeholder, or you can write it like this. Now if you run this code, it will have the same effect, but will not have the text before here. So now you get 1 until 10. Now there are other variations to use this range, and one of them is to use until. So let's comment this code. So let's press Ctrl/. Right? Now let's type 4 again. And now I'm gonna call it also I. Here you can put whatever name you want. And instead of now I'm gonna put also again the in keyword. And instead of putting the dot to loop to a range, I'm gonna put 1 until 10. Alright? Now I'm gonna add the println statement, and here I'm gonna type I, and this will have the same effect with a single difference, that 1 until 10 is gonna exclude 10, and 1 using the range dot 10, it will include 10. So if you run this code, you're gonna see that you will not have 10 here, because 10 is excluded when you're using the until. So now as you can see, we have 1 until 9, and 10 is excluded because now we're using the until. So if you're using the range, which is dot, the last number is gonna be included, but if you use until, the last number is gonna be excluded. So it's important to know that these two, respectively the until and the range, can only count upwards. So we cannot put here 10 until 1, because the first number, the number on the left, needs to be smaller than the number on the right. So we cannot put 10 until 1. We can only count upwards. You can only put 1 until 10, or 1 dot 10. So to loop backwards, we need to use another thing. So let's comment this code also. Now to loop backwards, we type 4. Again, in the parentheses you put I. Here you can put whatever if you want. In. So here you can put whatever name, but conventional is I is used. Now I'm gonna put in, and now I'm gonna put down. First let's put 10, down 2, 1. Let's add the curly braces, the println, and let's put I here. Now this is gonna count downwards. Now it's gonna count from 10 to 1. So if you run this code, now I get 10, 9. So it's counting backwards, right? Another thing that you can do is that you can introduce an arbitrary step. So let's comment this code also. Let's add below another code, another for loop. So here I'm gonna type 4 parentheses. Let's put I, and let's use the until. So in 1 until 10. So now I can put an arbitrary step. So at this arbitrary step, that number which is at that arbitrary step is gonna be skipped. So I can put here step 2, let's say. So now I'm gonna put the curly braces to have some code executed. I'm going to put println, and let's put here I. So now if you run this code, now you get 1, 3, 5, 7, and 9. So you can see that at the second iteration, the number is skipped. So we have 1, 2 is skipped, then we have 3, 4, 3 and 4 is skipped, and so on. So you can put this arbitrary step if you want. So let's comment this code also. And let's add the first code that we had here to talk a little bit more. So let's put I in 1. Let's put the range .10 and curly braces. Here I'm gonna type println. I. Now if run this code, we'll get the same output as at the beginning of the video. So get 1 until 10 inclusive. Now again, what this loop is doing is going through this to this range from 1 to 10, and it's executing the code inside the curly braces 10 times, and when it reaches 10 it stops and it executes the next line of code below here. But because here we don't have any line of code, our program exits and is finished. So this is our discussion about for loop. There are other loops which can loop as long as a certain condition is true, not as long as a certain number is reached. So we're gonna look at the next loops in the next video. See you next. Alright, now it's time to look at the next two loops that you can use in Kotlin, and those are the while and the do while loop. But first, let's open our previous project called loops, because I'm gonna type my code there. So open your previous project, and here I already have deleted the code that we had previously here, but if you have the code, delete it, and let's start our discussion about the while loop. So first I'm gonna type while. This is how you declare the while loop, and here you can press enter to fill in the while key and the parentheses for you, or you can type manually the while and the parentheses. So I'm gonna press enter to fill that for you, fill in that for me. And next you put a space and you put curly brace here. So I'm gonna put the left curly brace and press enter, and the right curly brace is gonna be added automatically, as you can see on the line 5. Now, a while loop loops as long as a certain condition is true, in contrast to the for loop, which loops for a specific number of time. A while loop loops as long as a condition or an expression is true. So this gives us more flexibility in circumstances where we don't know for what specific number of times we want our code to be repeated. So we put our condition inside the parentheses here, and as long as this condition is true, the code inside the curly brace is going to be executed repeatedly. So let's see how we can do that. So first, let's declare a variable here. I'm going to call it number, and I'm going to assign a value of 0 to it. And here I'm going to type while number is less than 10. Inside the curly brace, I'm going to type the println function, and we're going to output the value of our number, and then we're going to increment the value of our number. So I'm going to put number, I'm going to use the increment operator, plus, plus. Let's put a space here to have things more clear. Now, if you run this code, you're going to see the numbers from 0 to 9. So what is happening, how this works? First, we've declared a variable, we assign a value of 0 to it. Next, we loop using the while loop. And first, the while loop is checking to see if this condition inside the parentheses is true. So it checks to see if the value of our variable number is less than 10, and it's true because we have 0. Then it executes the code inside the curly braces, and it outputs the value of our number in the console using the println function. Then it increments the value of our number, and then it loops again. But now the value of our number is 1. So now it will compare again if the value of our number is less than 10, which is true. It will loop again, it will output its value, it will increment its value, so now we have 2, and so on until it reaches 9. When it reaches 9, it will increment the value. It will output the value in the console, it will increment its value, then it will check again to see if this condition is true, but now the value is going to be 10 because it was incremented when it was 9. And this condition is going to evaluate to false, and the code inside the curly braces is not going to be executed. This is why we don't have 10 here. And it executes the code that comes below our while loop. But because we don't have any code, the program is terminated. And you can write this thing in one single line, but it's recommended to use this form only if you know that you have one single statement in your loop. So if I can delete this too, and I can put here directly number plus plus, and because this returns the value, it increments the value and it returns the value, it's an expression, I can run this code and it will have the same output. But if I delete the increment operator after the variable, and if I put it before, now you're gonna see a different output here, because this increments the value of our number, then it decrements the value of our number, and this is called prefix increment. So this is called prefix incrementing, and the previous one, let's press Ctrl Z, this is called postfix increment. So this is postfix because it's the end of our variable, and if you put the increment operator at the beginning of our variable, is called prefix increment. Anyway, let's press Ctrl Z to have the code that we had previously and the curly braces. Now look what happens if I delete the increment, if I don't increment our variable now. Now let's talk what is happening. Because we don't increment the variable and the variable always has the value of 0, this will always be true, and it will execute the code inside the curly braces forever. So we'll have what is called an infinite loop. So if you run this code, now you can see that it prints 0 forever, because this condition never evaluates to false. So let's stop this by pressing on this red square. So now the process, the program is terminated. So this is why you need to increment the value of our number, because we want that condition to be false at some point in the future. Next, let's say that I assign here 10. So if I run this code, now this condition is going to be false because 10 is not less than 10, and the code inside the curly braces is not going to be executed. So now we have no output here because this condition is evaluates to false, and it's not executing the code inside the curly braces. But there are certain situations where you'll want to have your code executed at least once, even though the initial condition or the initial expression is false. So if I delete the curly braces and the code inside the curly braces here, now to do what I said, to execute the code even though the condition is initially set to false, to execute the code at least once, you need to use a do while loop. And to use a do while loop, you put here a do, press enter to add the curly braces, and we put our while at the end of our enclosing curly brace of our do. And here inside the curly brace, I'm gonna put our println function, and I'm gonna output the value of our variable number. So now if you run this, now get 10, because this executes the code inside the curly braces at least once, and after that it comes down here and checks to see if this condition is true or false. And if this condition is true, it will repeat the code, but if the condition is false, it will not repeat the code. But the important aspect here is that it will execute the code inside the curly braces at least once, irrespective of our condition, if the condition is true or false. In our case, it's false. So these are the 3 loops that you can use in a Kotlin: the for loop, the while loop, and the do while loop. Now it's time to see how you can use the continue and the break keywords with those loops. So let's press Ctrl Z to undo the code to have the while loop back, because I'm going to start with the while loop and to see how we can use the break and continue keywords with the while loop. Let's bring this up a little bit. So let's first look at the continue keyword, and the continue keyword can be used to bypass a section of code. So let's say that I want to skip the number 7 in our loop. So I can type here if our variable number equals 2, so 2 equals 7. Let's put curly braces, press enter to add the right curly brace, continue. So now what this is gonna do is when it's gonna reach the number 7 and this condition is gonna be true, it's gonna call continue and it's gonna bypass the code that comes below of our if statement. So if you run this code, look what happens. It happens nothing, because here our number has a value of 10, so this condition is false, so the code is not executed. So let's put here 0. Now if you run this code, so you get 0, 1, 2, 3, 4, 5, and 6. But and you see that at 7 it skips the code. But why you don't have the next numbers? This is because unintentionally we created here an infinite loop. So let's stop this and to explain. So what happens here is that because we say here explicitly to check here explicitly, we check here to see if our number is equal to 7. Then we're gonna continue. In other words, you're gonna skip the code which comes below of our if then statement. Then this code is never called. So this code is never called, the println, and more importantly, the increment operator is never called on our number variable. And because of that, because our variable is not incremented here, when it's gonna loop again, it will have again the value 7. So this condition in the if is gonna evaluate again to true, and it's gonna call continue again. And because this code again is never reached, this code, and the value is not incremented, it will still have the value 7. So this is gonna evaluate again to true. So it does this forever. And to change that, we need to put our number and which is incremented before our if, and that is gonna solve the problem. So now if I Now if I run the code, let's increase this. Now get 1, 2, 3, 4, 5, and 7 is skipped, then 8, 9, and 10. Because now when this condition evaluates to true, it will continue. It's not going to print the code. It's not going to be executed below of our if. And it will come back to loop, and now it's going to increment the value, and the value is going to be 8 instead of 7. This is going to evaluate to false, and the continue is not going to be called. And it will print the number 8, and it will do the same for it will increment the value again, and then we'll have 9 and so on. So this is how you can use the continue keyword, and you have to be careful where you put where you increment your variable, because as you saw, you can easily get into an infinite loop. Now you can have a more complex expression here. So you can put here if number is greater than, let's say, 2, and number is less than 8. Now if you run this, look what happens. Now you get 1, 2, and then we get 8, 9, and 10. Because what this condition now checks is if our number is greater than 10 and less than 8, then continue, then skip that number. So this is why the numbers between 2 and 8 are skipped, because we call continue on them. And if you hover over here, you see that it says the two comparisons should be converted to a range check. So we can write the same condition that we have here using a range, but this is different from a range that you've used in a for loop, in the sense that this is now checking to see if our number is in the range from 3 to 7. So if you run this code, now I have the exact same output, but now we are using the range to check to see if our number is in that range. And if it is that range, we call continue to skip that. The next thing that you can do is you can break the loop. You can stop the loop using the break keyword. So I can say here again, if number equals, let's say 7, call break. So I'm going to type here break. Now when this condition is going to evaluate to true, it's going to call break and the loop is going to stop. It's not going to execute any line of code after that. It's going to stop, it's going to leave, and it's going to execute the code which comes below of here. But in our case, we don't have any code. So you see that we have 1, 2, 3, 4, 5, and 6. And when it reaches 7, it breaks and it's stopping the loop. It's not printing the value, and it executes the loop. So it terminates. So and we can do the same thing with a for loop. So we can use the continue and break with a for loop. So you can type here for, let's say I in, let's create let's say 0 to 10. Let's create this range. Let's add the curly braces. Now I can say here if I in, let's say 3 to 8, then continue. Let's print the value. Let's type here println. Let's print the value of I here. So now if you run this code, so we have our first loop, which loops to 6, and then it breaks because you call break there. Then it's using the for loop, it loops from 0 to 10, but because here we're checking to see if our number is in the range 3 to 8, then skip it. You get 0, 1, 2, and then the numbers, the 3 and the numbers between the 3 and the numbers between 3 and 8 inclusive are skipped here. So we have 0, 1, 2, and then the numbers between 2 and 9 are skipped, and we have 9 and 10. And we can use also the break keyword with the for. So I can put here if I equals 7, break. So now if you run this code, now you get 0, 1, 2, 3, 4, 5, 6, and when it reaches 7, it breaks, similar to our while loop. So this is how you can use the break and continue keyword with the while and for loop, and you can use the break and continue keyword also with the do while loop. Next, we're going to look at how we can nest loops within each others, and we're going to look at an example using the while loop. So I'm going to delete the code of the for loop and the println statement there. I'm going to delete the if then statement, the break keyword, and I'm going to bring the println function up there. Down here I'm going to declare a variable. It's going to be a var. I'm going to call it I, and I'm going to assign a value of 0 to it. Now, inside the while loop, I'm gonna type another while loop. Here I'm gonna put a condition while I is less than 5. We're gonna increment I, and we're gonna gonna output the value of I in the console. But let's put some text here to make clear what loop is looping. So I'm gonna put 3 asterisk signs here. I'm gonna type the $sign and I. So now if you run this code, let's also change this condition to less than 5. So if you run this code, now we get, first we get 1, then we get our code inside of our inner while loop, which is the 3 asterisks, and we get 1, 2, 3, 4, 5, then it loops again. But let's take this code line by line to explain what is happening here. So first we declare this variable call number, we assign a value of 0 to it, then we loop using the while loop, the outer loop, and it checks to see if this condition is true, and it's true, 0 is less than 5, so it executes the code inside the curly braces, and it increments the value of our number by 1, then it outputs the value of our number in the console, so we get here 1. Then it declares this variable called I, and then it starts looping inside our outer loop while using the inner loop while, so it loops here 5 times. So when it finishes, it goes back, and now the value was incremented by 1, it will check again if the condition is true, it will execute the code inside the curly brace, it will increment the value now, so it will have 2, it will output that value, so now we have 2 here. And then it will loop again 5 times using the inner loop, and it will do the same thing for the next round and the next round until we get to 5. When we'll get to 5 will not be less than 5, and this condition will evaluate to false, and the code inside the curly brace is not going to be executed. Alright? And you can use the break keyword inside the inner loop. So I can say here if you can put it above here, so I can say if I equals 0, then break. And you can put the break and continue keywords in one single line if you want. You can avoid the curly braces. So now if you run this code, now get 1, 2, 3, 4, 5, because now when it reaches the inner loop, it breaks immediately at every iteration in the outer loop. So when it comes down here, it will check to see if this condition is true. It's going to be true, but when it gets to the if statement, it will break, it will stop the loop. So it will execute only the outer loop. And with a break keyword, you can not target only the loop. So with this break keyword, we stop only this while loop that we are currently, that is currently the nearest loop. But there is something which is called labels, and with labels you can target an outer loop. So you can break the outer loop here. So you can break the while loop which is here. And to do that, we give to our while loop a label. So we type here a name. I'm going to call it outer, and we put at. Now here you can put break, and now I'm going to type at, and you put outer, and this should be a single word. Now if you run this, look what happens. Now you get 1 because it breaks the outer loop. So it first evaluates this condition, it increments the value of our number, it prints the value of our number, and then it goes in the inner loop, it checks to see if this condition is true, it's true. Then it checks to see if I is equal to 0, which is true. Then it breaks, but now it's not breaking this loop, this inner loop, it's breaking the outer loop. So it's breaking this loop. So this is why you get only 1, and the code is not executed because it breaks the outer loop, and the code, our code, it's terminated because down here we don't have any code. So this is how we can use labels with the break keyword to target an outer loop, and the labels can be used also with the continue keyword and in other loops that we've looked at. So this is our discussion about loops. What you can do, I should say, is that you cannot target with the labels an inner loop from an outer loop. So you cannot, you can give here a name to a label to our inner loop, but you cannot target our inner loop from our outer loop. So this is our discussion about loops, and in the next video we're gonna do a challenge. Alright, so now it's time to do a challenge using all the knowledge that we have accumulated so far, and I'm gonna use the previous project to put my code there. But if you don't have the previous project, you can create a new project and give it whatever name you want and type your code there. So I'm gonna open my previous project. I'm gonna delete the code inside the main function. Now, what is the challenge? The challenge is to create an arbitrary range of numbers. Then you need to find a way to go to that arbitrary range of numbers and to determine if a number is an even number or if a number is an odd number. And based on that, if the number is an odd number, skip that number. But if the number is an even number, then output that number in the console. Additionally, you should create a way to count all the even numbers that you found in your range and display the total numbers of even numbers at the end of your program. So try to do this solution, and after that you can watch my solution to this. So first I'm gonna declare a variable called number. I'm gonna assign a value of 1 to it. Next I'm gonna declare another variable, but this is gonna be a val. It's gonna be called last number, and it's gonna have a value of 20. Now I'm gonna loop using the while loop, and in the parentheses I'm gonna type while number is less than equal to last number. Then I'm gonna put curly braces. Now I'm gonna increment our number. Now here we need to add the logic to determine if a number is an even number or not. And to do that, I'm going to add the function at the end of our enclosing curly brace of our main function. So I'm going to type here the fun keyword. Now you need to give a name to our function. It's going to be called is even number. I'm going to put parentheses, and it's going to take a parameter called number of type int, this function, and it's going to return a boolean value, true or false, this function. So you put colon and we type boolean. Then you put curly braces, and now we add the logic to determine if a number is even or not. So you type here if, and now inside the parentheses we put another set of parentheses, and here we refer our parameter number that we have defined above, and here we put the modulus operator, because the modulus operator gives us the reminder of a division. So we put the modulus operator 2. Now, outside our inner parentheses, we put equals 0, then we put curly braces, and we return true. Else, we're gonna return false. Now, how this logic works? So, our number parameter, which is defined here, is gonna take an argument. Let's say that it's gonna take an arbitrary number. Then it's gonna check to see if that number divided by 2 has no remainder. If it has no remainder, then that number is an even number, because even numbers, when they are divided by 2, they have no remainder. And if that is the case, if the remainder equals to 0, our number is an even number, and it's gonna return true, and the else part is not gonna be executed. Now let's add the logic here. Let's use our function here, because as you can see now it's gray out, it's not used. So let's type here if, and in the parentheses we're gonna type is even number, our function. We're gonna call our function here, and we're gonna pass a parameter to it called, now I'm gonna pass the parameter, we're gonna pass an argument, and the argument is gonna be the variable that we define above. As you can see, you have the v there, so press enter to fill in that for you. Let's press Ctrl Alt L to format the code. Now, if you press Shift Control P on this, you're gonna see that this is a Boolean expression because this returns true or false. So we can put the logical NOT operator in front of it to change its value, to switch its value from true to false and from false to true. So let's put curly braces, and here we're gonna call our continue keyword. Down here I'm gonna add a println, which is gonna output the number in our console. Next, we need to add the logic to count the total even numbers which are found. So I'm gonna declare var. It's gonna be even numbers counter, and I'm gonna assign a value of 0 to it. And here we're gonna increment our even numbers counter. So now if you run this code, we get 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So these are the even numbers that our program found and is correct. But let's add a println at the end of our loop to print the total number of even numbers found. So let's put println here, and let's refer our even numbers count here. Even numbers counter. So if you run this, let's put some text actually. Let's put this in curly braces. So let's type here total number of even numbers found equals $. Now if you run this, now you get total numbers of even numbers found is 10, and this is correct. And it outputted correctly our even numbers, and it showed that the total number of even numbers found is 10. So let's now think about how this logic works here. So let's look at the if statement that we have here. So what is doing this thing here? So let's take an specific example, a specific number to see how this works. So let's say that here we pass 4, and it's gonna use the logic to determine if this number is an even number, and if that number is an even number, it's gonna return true. So this function, which is a Boolean expression, is gonna return true, and then we're gonna negate this value. We're gonna change this value from true to false, and continue is not gonna be called. And the code which comes below, which is our variable, which counts how many even numbers we have, it increments, then it outputs that number in the console. So we have our even number 4 output it in the console. But if you pass here 3, that number is not going to be an even number because it has a reminder, and this is going to return false. And because here you put the logical NOT operator, that is going to be switched to true. And the continue keyword is going to be called, and our code which comes below here, which is our variable even number counter, is not going to be incremented. And our number, respectively our number 3, is not going to be outputted in the console. So this is how this works. So this is our solution to our challenge. Of course, you can simplify this. So if you hover over here, because you have all of those underlines, you can see that it says remove redundant if statement. So this can be simplified to this. This does the exact same thing. It is going to return true if this divided by 2 has no reminder, otherwise it's going to return false. And this can be simplified even further, because here we have a single expression, and we know when we have a single expression, we can write our function as a single expression function. So we can remove the curly braces here. We can remove the Boolean return type. You can remove the return keyword, and you're gonna put the equal here. And this, now if you run this code, this will work the same. So we have the same output here. Now I use the function here because we've talked about functions in our previous videos, but you can remove the function completely and add the logic to determine if an even number is even or not directly in the if statement. So you can put here if, let's put parentheses, our number. Now we're going to use the modulus operator to is not equal to 0, then continue, and this will have the same effect. So if you run this code, this will work in the same way. So we have the same code here because this does the exact that the function did previously. It will check to see if this is an even number. If this is an even number, this is not going to be true because here we're checking to see if this is not equal to 0, and our number is equal to 0. So this condition inside the parenthesis is going to be false. The continue is not going to be called, and our code below is going to be called. Our even number counter is going to be incremented, and our number is going to be output in the console. So this does the same thing as previously. And we can do this challenge also with a for loop if you want. So you can type here for I in 1 to 20, then execute the code inside the curly braces, and here you can check if parenthesis again, if I percent 2 not equal to 0, then call continue, then else is gonna execute the code which comes below here, which is, let's first assign a value for to a even number counter to 0, because when we're gonna enter in the for loop we should have 0 to not have the previous value which was 20. So let's put 0 here, and here you can increment our even number counter plus plus, and we're gonna print our even number. So I'm gonna print I here. So if you run this code, let's run it from here. But let's add the println to make things more clear. So I'm gonna add here print. Let's put quotation marks, and here I'm gonna type total number of numbers found using for loop are, let's put the dollar sign. Now let's refer our even number variable. Now if you run this, now we have the exact same output, but now we're using the while loop, then we're using the for loop. So let's add a println statement between our loops to make clear which loop is looping. So let's add a println here, and let's type here, now we are looping using the for loop. So now if you run this, it will make more clear which loop is looping. So now, as you can see, first the while loop loops, then we have our println, which says that now our for loop starts looping, then we loop with the for loop, then at the end we output the total number of even numbers found with the while loop. We have 10, then we output the total number found, the total number of even numbers found using the for loop, and R10. So our code works perfectly well. and this does not represent the best way to solve this challenge. Of course that you can find a total different way, a better way to solve this. So this was just my way of solving the problem. So see you in the next video, and I hope that you enjoy this challenge. So now it's time to start a discussion about arrays, but first let's create a new project. I'm gonna call it arrays. For the language, select Kotlin. For the build system, IntelliJ. Make sure to have the JDK selected, and check this little box, add sample code, to have the main function auto-generated for us, and click on create. Alright, now let's delete the code inside the curly braces of the main function. Let's hide the project pane, and let's start our discussion about arrays. And so far in our videos, we've only looked at how we can store only one single value in a variable. And that is very useful, but what if you have a large amount of values that you want to store in our variables? Let's say that you want to store 30 or 40 different values in our variable of a certain type. Of course that you can declare a variable for each of one of those values and then assign it to the variables. But what happens if you have 1000 or 20,000 values? In that case, it will not be practically possible to write each one of those variables and then assign a value to it. And Kotlin help us here because it provides us arrays, and an array allows us to store more than one single element in a variable name. So it allows us to store more elements in one single variable name. Now, to declare an array, we type val. Here we type names. Next, we need to provide a type, and the type is going to be an array. And IntelliJ has given us some suggestions there, so press enter to fill in that for you. And now we put angle brackets, and inside the angle brackets we're going to put what kind of data this array is going to store. So it's going to store string or text or sequence of characters. Then you put equals, and here we don't type a literal value. Here we type a function call, and here we type array of, and now we put our elements inside the parentheses of the function call, separated by comma. So I'm gonna put three names here. So I'm gonna put John, Steven, and Megan. Now let's see what we have here. So first we have the val keyword. Next we have a name for our variable, and the name is names. Then we have the type, and the type is an array, which means that we can store multiple values in our variable. And next we have angle brackets and string, and this means that this array is gonna store text or sequence of characters. It's gonna store only strings. And then we put equals, we have the function called array of, and then we put our elements of type string, which is those names, separated by comma. But because Kotlin has type inference, here we can delete the type, and the type is going to be inferred in the same way it was inferred previously when you just declare a simple variable. So now the type is still inferred as an array of strings. And now is a good moment to introduce type hints, but we need to activate the type hints from settings. And to do that, you can go to file and click on settings, or you can press the shortcut that we have here for our particular system, and for Windows is Ctrl Alt S. So I'm gonna press Ctrl Alt S, and here we go to, if you have something like this, you go to editor, click on this greater arrow in front of editor, and then you go down here where it says inline hints. Click on this greater arrow in front of inline hints, and from those options select Kotlin, and here you go to types and select local variable types, then click apply and OK. Now what we have here on the right of our variable name is a hint, so it's not real text. This is just there to remind us what kind of type this variable has, and in our case is an array of string. And my suggestion for you is to keep those scenes activated, because in this way you'll always see what type a variable is without explicitly declaring the type. So this is not this is just there to help us, to remind us what kind of type a variable is. Now let's say that I want to output a certain element in the array in the console. To do that, we cannot just type here println and pass names, because we need to be more specific than that. We cannot pass the array here. And to get a specific element in the array, you need to know that the elements in the array are stored at indexes, and the index of an array always starts at 0. So the first element is stored at the index 0. And to get the first element, we type here square brackets and we put 0. And that, if you press Shift Control P on it, it's a string, because that is gonna return us the first value in the array, which is John. So if you run this code, we get John. But let's put some text here to make it more clear that this is the first element. So let's type first element. Now let's choose the $sign, because this now is a placeholder, and let's put the curly braces around our element and the quotation mark here. Now if you run this code, you get first element John. Let's put here some. So you get the first element John, because John is stored at the index 0. And in the same way, John is stored at the index 0, Steven is stored at the index 1, and Megan is stored at the index 2. So our index starts at 0. The index of an array always starts at 0. And you can replace a specific element in the array also using the index operator. So you can type here names, again square brackets 0 equals. So now I'm gonna assign a new value to our element stored at index 0, which is now I'm gonna put here the value Alex. So now if you run this code, now get first element Alex, because John, which is at index 0, was replaced with the value Alex. So now we have Alex, Steven, and Megan. But what you can't do is you cannot get an element at an index that doesn't exist. So we cannot get here, let's say, an element at the index 4, because if you run this, look what happens. We get an error which says array index out of bounds exception, index 4 out of bounds for length 3. That is because the index 4 doesn't exist, and here we try to access that value, and that value and that index doesn't exist. And this is called the runtime error, because this error is called only while our app is still running. So you don't have here an error like we have for here. You don't have a compile error which you saw in our previous videos. That is because the size of an array is not known until at compile time. Also, it's very important to know here that the size of an array is fixed. So this will always have the size 3, and the only way to add new elements to it is to put the elements directly here. But there is not another way to, let's say that I can put another element in the array down here. We can only replace elements. And then in the next videos, you're gonna see that there are other arrays which are more flexible in the sense that they can grow and shrink. We can add or remove elements from those arrays. But for now, we're gonna look just at this array. So let's change this back to 0 to don't have that error. And to avoid this kind of errors, you can check to see what is the size of the array. In other words, to see what is the number of elements stored in array using the size variable. So let's do that. So I'm gonna add the println statement below of our first one. So I'm gonna type here println. And here I'm gonna put the text, the size of the array is. And here I'm gonna put the $sign, curly braces. Now I'm gonna use our names array. And here I'm gonna put dot size. And this is gonna give us the size of the array, or it's gonna give us in other words, the number of elements which are stored in this particular array. So if you run this code, you're gonna see first output, the first element is Alex, and then you're gonna see the size of the array is 3. So we get first element Alex, and the size of the array is 3. And this is very important to note that the size of the array is always 1 times greater than the last index in the array. So we have an array which starts as index 0 and ends at index 2, which has a size of 3. So it's very important to remember this to avoid crashes in your programming. And of course that you can put other data types in your array. So I can declare another array here, also val, called numbers. And we can use the array of again. And here I can pass some numbers. And now you see the type is an array of int, or an array of integers or whole numbers. And you can also mix types here. So you can put here numbers and strings. So now we have an array, and this, which is between our angle brackets, you don't need to understand this for now, but this allows us to have array of 2 types, respectively of type int and of type string. And you can put also a char here if you want. Let's say A. So you can create an array of any type if you want. So this allows us to mix our types in the array. And because we've looked at loops and how we can use loops, you can use loops to loop to this array. So I can put here, let's say that I want to use the first array, so I can put here for name in names. Now I'm going to refer our array of strings. Then print ln name. So now you see that we have this type hint for our name variable that we have here. Of course this can have whatever name you want. Now if you run this, you're gonna see our 3 names outputted down here in the console. So now we have Alex, Steven and Megan, because now we're using the for loop to loop through our array names. And this is interesting, but what if you want to loop through our array numbers, which is a mixed array? We have numbers and strings and chars. We can refer it here. Let's call it I in and now you see the type that was inferred for the I is this comparable that we have here. So this is gonna loop through our mixed array. So we put here I. Now if you run this, you're gonna see our numbers and then our name 1 and our char outputted down here. So now we get first element Alex, which is our println statement, then the next println statement, the size of the array, then we have our numbers in our numbers array, and then we have our name 1 and then we have our char. So this allows us to loop through our mixed arrays. But what if I want to output only if I want to output in the console only the integers in this mixed array called numbers? To do that, and this is a good way to introduce the is keyword. And with the is keyword, we can check to see if a literal or a variable is of a certain type. So I can put here if I is, let's say, an int, then and only then we're gonna output its value in the console. Then we're gonna call our println, and we're gonna pass our I variable to our println function. Now, if you run this, you're gonna see in our loop only the numbers here, only the integers, because this is keyword is checking to see if our I is of type integer, and this is gonna return true or false. In our case, it's gonna return true for our for all of our numbers that we have here. So we have 4, 5, 6, 7, and 4 again. And you can check to see if this is a char, and we're gonna see in the console only our single element A outputted down here. So we have A, or you can check to see if this is a string, this element that we're looping at this particular iteration, let's say. So if you run this, you're gonna see in the console only name1, because only name1 is of type string. So you get name1. So this is very important to know that with the is keyword, you can check to see if a variable or a literal is of a certain type or if it's not, and based on that to execute some code. In our case, you output that value in the console if that condition is true. So this is how you can use the is keyword and the for loop to loop through our array, and the is keyword to check to see if an element in our array is of a certain type or if it's not. And let's change our array numbers to a different name, because numbers is very specific. It implies that we only have numbers in this array, but we have a mixed type, so we have multiple types in our array. We don't have only numbers. And to do that, instead of changing our numbers array in everywhere in our code where you're using this variable, we can right click on it, go to refactor, and click on rename, or you can click Shift F6. Now, if I change the name of our array numbers, it will be changed everywhere where you call this variable. So look, if I delete now the name is also changed in our line of code 9 we're using in the loop. So now if I change this to, let's call it mixed elements, if I press enter, now this will be also changed everywhere where we call our variable, respectively on the line 9 here. So now we have our array numbers changed to mixed elements, which is more descriptive because it implies that we have an array of mixed elements. So now it's time to do a challenge using the knowledge that we have about arrays. But first of all, I'm going to delete the code inside the curly braces of the main function, because I have the previous project opened. Now, the challenge is to create a function which is going to take as an argument an array of integers. Then you need to figure out a way to determine which number is the biggest number in that array. Then you need to return that number to the function. And you need to create another function which is gonna do the same thing, but is gonna figure out what is the minimum number stored in that array, and then it's gonna return that value. And third, you need to find a way to combine those two functions in just one function, which is gonna return the maximum value stored in that array if you want, or if you don't want it will return the minimum value. So try to solve this challenge and then watch my solution. Now let's solve this challenge. So first I'm gonna create a function which is gonna be called find max. This function is gonna return the maximum value, and it's gonna take as and I'm gonna define here a parameter and an array. So here I'm gonna type a name for our array. It's gonna be called numbers, and it's gonna have the type array of integers, and it's gonna return an integer. Now, here I'm gonna declare a variable. It's gonna be a var, and it's gonna be called max. And in this max variable, I'm gonna store the first value in the which is in the array. So I'm gonna type here numbers, square brackets, and I'm gonna use the index 0 to get the first value in the array. Then I'm gonna loop through this array. So for number in numbers, then here we're gonna check to see if our number is greater than our first value which was stored in the array, our max value. And if that is true, then we're gonna store this value, which is now greater than our maximum value, in our max variable. So here I'm gonna put max. Now it's gonna be equal to this number, which is found to be greater than our previous max value. And at the end of this loop, we're gonna return the maximum value. And we're gonna do the same for finding the minimum value. So I'm gonna copy this code. And this is gonna be called find min. But here we're gonna change a little bit the logic. Let's call this variable min. And here we're gonna change the condition to less than min. Now let's call those function in our main function, and let's pass some arrays to see how it works. So first I'm gonna declare a variable. It's gonna be a val, and it's gonna be called max. And now I'm gonna call our find max function, and here I'm gonna pass an array, and I'm gonna pass the array directly here. So I'm gonna type array of, and I'm gonna pass some arbitrary numbers like then I'm gonna create another val. This is gonna be called min. Now I'm gonna call find min, and here I'm gonna also call our array of function, and here I'm gonna define some arbitrary numbers again. Now I'm gonna output those values in the console. So I'm gonna add println here. I'm gonna type max value is $, and I'm gonna refer our max variable defined above. Another println. Now if you run this code, get max value 7, which is correct. This is the biggest number. And then we get minimum value is 4, and this is also correct. So our code works perfectly well. Now the next thing is to combine those two functions that we have here. Let's decrease this. Now you need to find a way to combine those functions in one single function, which is gonna also return the maximum and minimum value, but only if I want to return to be returned. So I can determine if I want the minimum value to be returned by that function, or if I want the maximum value to be returned by that function. So I need to find a way to combine those two. And to do that, I'm gonna delete our second function. I'm gonna delete the code inside this function, and I'm gonna change the name of this function to find min and max. And now here I'm gonna define a parameter which is gonna be a boolean, which is gonna have a boolean type. So I'm gonna call it search max, and it's gonna be a boolean. All right. Now, based on that boolean value, if it's true, if I want to search the maximum value, here I'm gonna type an if statement. So I'm gonna put if search max, then I'm gonna add here the code to search for the maximum value. But first, let's define a variable here. It's gonna be also var, and it's gonna be called max, and it's also gonna have the first value in the array, which is as in the 0. Now, if our search max is true, then we want our maximum value to be search and return. So I'm gonna add here to the code to do that. So I'm gonna type here a for loop, which is gonna go through our numbers array. And here I'm gonna add the if statement, which I'm gonna check to see if our number is greater than our max. Then I'm gonna assign our number to our max. Now I'm gonna go down here, and here I'm gonna add the else part. So if this argument which is passed to our parameter search max is false, so I don't want to search for the maximum value, then that means that I want to search for the minimum value. So I'm gonna put here else. Now I'm gonna add the code to search for the minimum value, and for this we need to define also a variable here. It's gonna be called min, and it's gonna have the value of max. I'm gonna explain in a minute how this works. Now here we're gonna also loop in our numbers through our numbers array, and here we're gonna check if essentially we have the same code that we have in our find min function. So here we're gonna search if our number is less than our min, then we're gonna assign our number to our min. Also, we need to return this value at the end of our loop. So here we need to return max, and here we need to return min. Now let's press Ctrl Alt L to format the code. Now let's delete the code that we have here. Let's delete also this code. Now I'm gonna put our find min and max function directly in the println statement. So I'm gonna type here or to put in a variable first. So let's put in a variable first. So I'm gonna define a variable. It's gonna be also max, and here we're gonna type find min and max. Now here we need to pass an array first. So we need to call our array of. We need to define some numbers here. Let's say 20, 40, 50. Now we need to pass an argument to our parameter search max, which is going to be either true or false. So first I'm going to pass true here. Now if we print this value, if you output this value in the console, let's say that we type here the max equals to $, I'm going to refer our variable. Now if you run this code, we get the maximum value is 100, which is correct. Now let's duplicate this code that we have here. Let's try it for the minimum value. let's call it mean. And let's add the println statement down here. Let's type the mean value is $mean. Now if you run this code, and let's pass here false. Let's run this code again. Now we get the maximum value is 100, which is correct, and the minimum value is 20. And we did this with our find min and max function by combining our two previous functions. And our code until now works okay. Now it's time to have a discussion about how this solution to my challenge works. So now let's see how our logic inside our find min and max function works. So first we declare our function find the min and max. Then we declare two parameters, which is one is numbers and is of type array of integers. So here we're gonna pass only an array of integers. And the second parameter is called search max and is a boolean. So we can pass here only true or false. Then we're gonna say then we say here that this function is gonna return a value. Next, on the line 9, we declare a variable which is called max, and we assign using the index operator the first element in the array in our max. So in this case we assign 20 in our max variable, and then we declare another variable called min, and we assign our max in our min, but our max has the value of 20 because we assigned it here. So this variable min is also having the value 20. So both have the value 20 at the start. Then we check to see if our search max parameter is true or false. And if it's true, then we're going to execute the if part. And the if part works in the following way. First, we loop using the for loop through our numbers array. Then we check at each iteration if our number, let's say if 20 is greater than our max. So if 20 is greater than 20, which is going to be false. So the code inside the curly brace of the if is not going to be executed. Then we go for the next iteration. So here now we're going to check to see if our number, respectively 40, is greater than our max, which is 20. And this is going to be true. And because of that, the code inside the curly brace is going to be executed. So now we're going to assign to our max, which is now is 20, our number, which is 40. So now our max variable has a value of 40. And we're going to do the same thing for the next, for the 50. So this condition is also going to be true. So we're going to assign to our max 50, and so on, until it reaches 100, which is going to be also true. This condition is going to be true, and we're going to be assigning 100 to our max value. Of course, if we had another number here, let's say 2, it's going to loop for that number also, and this condition is going to be false for that because our number 2 is not going to be greater than max. And it's going to exit. It's going to exit the loop. It's going to terminate, and it's going to return the maximum value, which is 100, like we saw in our output in our console. And at this point, when we return our max value, the function is lived. So it's not executing any line of code besides our return max. It's not going to execute the subsequent code which comes below. But if our search max is false, it's going to execute the else part. So in this case, it's going to search for the minimum value. So here we have the same for loop. We search, you go through all the numbers, but here you're not checking to see if our number is greater than max. Here you're checking to see if our number is less than our minimum number. So you check to see if our let's take 20 30. You check to see if 20 is less than our minimum value, which is 20, and that is going to be false. So this code is not going to be executed inside the curly brace of the if. and it's gonna loop again. And now it's gonna check for the 40, and that's also gonna be false. So and so on, so on and so on until it reaches 100, which is also gonna be false. The loop is gonna execute and it's gonna return 20. Of course, that if we put here 2, let's say, now the minimum value is gonna be 2 because it's gonna loop for another iteration, and now one is gonna compare to see if our number, respectively 2, is less than our mean, which our mean previously was 20. That is gonna be true, and it's gonna assign our 2 to our mean. So if you run this code now you're gonna see that the minimum value is not 20, but it's 2. And after that, we return this value to the function which is called. So now I get the minimum value is 2, which is correct. So this is how this code works. And see you in the next video. So now it's time to start a discussion about object-oriented programming, and particularly in this video we're gonna look at classes and objects. But first I'm gonna create a new project. I'm gonna call it OP. For the language, select Kotlin, and for the build system IntelliJ, make sure to have the JDK selected. And also I'm gonna check this little box because this add sample code is gonna add the main function and that code for us. So I'm gonna click on create to create the project. Now I'm gonna delete this code and I'm gonna hide the project pane. Now, what is object-oriented programming? Object-oriented programming is a way of writing code, in a sense, in the way we think about the real world. So, in the real world, we have objects which can interact with each other and which can do stuff. But the objects in the real world have two major characteristics. First is the state. So the state of an object in real life is represented, let's say that we think about of a car. The state is represented by the color of that car, by the number of gears that car has, by the brand name of that car. So this is the state of a car. The next thing that real life objects have is functionality. So objects can do stuff. So let's take again the example of a car. A car can move, a car can stop, a car can switch gears. So objects in real life have those two characteristics, those two major characteristics represented by the state and the functionality. And the aim of object-oriented programming is to construct objects using code in the way they are in the real life. But to do that, let's say that you want to build an actual object in real life. What you first need to do? The first thing that you need to do, you need to create a template or a construction plan for creating that object, in which you're gonna define the generic things that a car has. And in programming, you will do the same thing, but instead of using a piece of paper or something on your PC to draw that template, in programming you're gonna use a class. So the class is used to create the template, which then is gonna be used to create an actual object, an object which is gonna have a specific state and a specific functionality. So in a way, you can think that the real world serves here as a model for us to write code. And in this way, by combining the state and the functionality in one entity and have an object, and as you can see, you can also have, like in the real life, objects communicating with each other. You're gonna see that this is really powerful because you can model your code in a more dynamic, in a more creative way. So this is what we're gonna do next. So first, let's say that I want to create an object of type car, and to do that, we go down here, and we need to define, as I said, the construction plan, the template for building an object. And in this case, we're gonna build the car object. So we're gonna define what is called a class, and we type the keyword class. Now we need to name our class. I'm gonna call it car, and the name of the class should start with a capital letter, and if it has multiple words, it should be in Pascal case. Then you put curly braces and you press enter. Now, inside the curly braces, we need to define the state and the functionality, as I said, for the objects that are going to be built with this template. And to do that, we need to use variables first for the state, or in the context of object-oriented programming, and more specifically in the context of classes, they are called classes and objects. They are called properties, and we define them like we define a simple variable. We type var, and the first thing that a car has is a name, a brand name. So we're gonna type name, but we cannot keep this variable uninitialized. We need to provide a value to it, and I'm gonna put an empty string for now. So it's gonna have the default value, an empty string. The next thing is the model, what kind of model this car is. So it's going to be also a string. I'm going to assign an empty string. The next property is going to be called color. It's going to be also an empty string. And the next property is going to be called doors. So this is going to store the number of doors that a specific object which is going to be built with this template is going to have. And we're going to put 0. I'm going to put 0 now. Now, we need to define some functionality for this class and for the objects, for an implicitly for the objects that are going to be built with this class. And I'm going to add two functions. First one is going to be called move. It's not going to take any parameters. It's going to just output some text to the console, which is going to say that the car is moving. So we put quotation marks. The car is moving. Now I'm going to define another function called stop. Also, it's not going to take any parameters. It's going to just output some text to the console. It's going to say that the car has stopped. Now, we have the template. We defined what our car is going to have. Now we need to create an actual or object, an actual and specific object using this template. And to do that, we first need to declare a variable, and it's going to be a val, and I'm going to call it car1. So our object is going to be stored in this variable car1. Then we put equals, and we type car, and now we have some suggestions, and we have our car that we define below, our car class. So we press enter, then we put parentheses. So now we have created an actual object, a real object, real in the programming sense, and but now this actual object also this is called instantiation, because we created an actual instance, but we don't need to bother with these names for now. So we created an actual object using this template that we have below, but the properties of these specific objects are those properties that we define here, those default properties. And to define some specific some specific values to these properties that this car object that we created has, we need to type car1 dot. So this is called informally dot notation. And now we have some suggestions. So we have our properties that we define for a car. And now we type car1 dot, and we choose the name. And now I'm going to assign a value to this name. It's going to be called Tesla. So now our car1 object that was created has the property name Tesla. Now we do the same thing for the next property, for the model. Car1 dot model. Press enter. And we put here as played, so the model. Next we also type car1 dot. Now we're gonna assign a value to the property color, and it's gonna be red. Next we type also car1, and we define for the property names, for the property doors, also a value. So we're gonna put here 4. So now our object car1 has for its properties some specific values. Respectively, have for the name Tesla, for the model S plate, for the car, for the color red, and for the doors 4. So now let's output the property values of this object that we created in the console. And to do that, we put our println function down here. We put quotation marks inside the parentheses because I'm gonna add some text here. So I'm gonna type name equals, we put $sign, then we put curly braces, and inside the curly braces we type car1 dot name, and this is gonna return the value of the property name for the car1 object that we created. Respectively, it's gonna return Tesla. Let's press Ctrl D 3 times to do the same thing for the next properties. And here we put car1 dot model, so this is gonna return the value of the model property. Here we're gonna put color, and here I'm gonna type doors. Now if you run this code, we get name Tesla. Actually, let's change the text here to model to match the property name. Model, color, and doors. So now if you run this, we get name Tesla, model S plate, color red, and doors 4. And those are the values of the properties of this object that we created here with our template car. Next, what we can also do, because in the class we defined two functions, we can call those functions on this object that we created. And to do that, we also use the dot notation. We type car1 dot move, and this is gonna call the move function, which is inside the car1 object. Let's also type car1 dot stop to call the stop function. So now if you run this code, we get the values of to our properties, and then we get the car is moving and the car has stopped. So car1.move and car1.stop is calling the functions on this object that we created here. Now let's also add inside the functions the name of the car that is moving. So to do that, we put here $sign inside the class, and we type name, and this is gonna reference this property name that is defined here. And let's also do the same thing for the stop function. Let's type name, and now what this is gonna do, because those functions are they are living inside this object that we created here, car1, and this object has the name Tesla. When those functions are gonna be called, they're gonna say that the car and the name of the car, which is in our case for our object is Tesla, is moving, and then it's gonna say the car again Tesla has stopped, because they are called on this specific object that we created, which has those specific values for its properties. Alright, so now if you run this code, we get as expected the car Tesla is moving and the car Tesla has stopped. So the functions are called on this object that we define here, and it's using the property values that we define for this object. But as I said, with you can create as many objects as you want using the same template, and let's do that. Let's create another object. So I'm gonna type here val car2, let's put equals, we type car, and then we put parentheses, and this creates now another object, but we need to define some values to its properties, because now the values for the properties are the default values that we define inside the class, respectively the empty string and the 0. And to do that, we type here car2 dot name. So now we are calling the properties for the car2 object, and now we define some values to the property of the car2 object. So they are this here is not overriding the value that we have here, because this thing that we have here, it's a distinct object in memory from this object. They are distinct objects, and they have their own properties with their own values and their own functions. And now let's put here Ford. Let's put car2 dot model. Let's put Mustang. Let's put car2 dot color blue, and for the doors let's put 2. car2 dot doors equals to 2, and let's output those values in the console. So let's output the values of the properties for this second object that we created in the console. And to do that, I'm going to copy this code. I'm going to paste it below here, and now I'm just going to change the variable to car2 to call the properties on the car2 object. So we put here car2. So now we're calling the properties values on our car2 object. And now if I run this code, now we get name Ford, model Mustang, color blue, and doors 4. And the first part is from our first object, which is name Tesla, model is played, red, doors 4, and the car Tesla is moving and the car Tesla has stopped. But let's add a space here to make clear that this is the output for the second object, to make things more clear. And to add a space, we put here a println statement. We put quotation marks, and we put a backslash n, and this is gonna add a space between our println statements. So it's gonna add a space between those statements and those. So now if you run this code, let's increase this. We get name Tesla, so this is our first object, model is played, color red, doors 4. The car Tesla is moving because we're calling the functions on the first object, and the car Tesla has stopped. And then we get name Ford, model Mustang, color blue, doors 2, and we have our space because we put here this backslash n, which adds that space for us. Let's decrease this, and let's also call the functions, the move and stop functions, on the second object. So I'm gonna type here car2 dot move and car2 dot stop. So now if you run this, let's right click and just click on run main.kt. Now we get our first object, which is with its value for the value for its properties. And then we get the two functions called on our first object, and we get then our second object with its values for its properties, and then we get the car Ford is moving and the car Ford has stopped, because now we're calling the functions on this second object, and this second object has the value for the properties, has different values for its properties. So this is why we get the car Ford is moving and the car Ford has stopped. Again, they are different objects, they are distinct objects created using the same template, the same construction plan. And I'm gonna end this video now, and see you in the next video. So in the last video we saw how we can create a class, and then how we can define some properties and some functionality to that class. Then we use that class to create two objects, and then we defined for those objects, for the property of those objects, some values. But the way we define values to the properties of the object is to call the object and then the property of the object, and then we assign a value. And this is okay, but if you have more than than 4 properties. Let's say you have 20 or 100 properties, that will be very tedious to write each one of them and then assign a value. And a better way is to use what is called a constructor. And as the name implied, the constructor is used to construct the object. And the constructor is called at the time when we create a new object. So at the time we type this line of code, when you finish to type this line of code, the constructor is called immediately. So that is the time where we need to pass the values to our properties. And to do that, we go down here where we define our class. We put at the end of at the end of the name of the class, we put parentheses, and here we define some parameters the way we define parameters for functions. And the first one is going to be called name. It's going to be a string. The second one is going to be model, also a string. The next one, color, also string. And the last one is going to be doors, and this is going to be an integer. Now, we need to assign whatever values passed to those parameters to the properties of the class here. And to do that, we just delete the empty string here and we type name. And as I'm typing, you see that we have name and it has this P. And this P stands for parameter. So you're saying, do you mean this parameter that we define up here? And we press enter to fill that for us. Then we type here model, color, and then doors. Now if you go up here, we have some errors because now when you create the object is expecting for its constructor some values. So if you hover over here inside the parentheses, it says no value passed for parameter color, doors, model, and name. So if you look down here, you see that it has this public constructor. So now what we need to do is to pass the value that we passed down here to the properties by calling them on the object, is to pass them directly in the constructor, and then the values, the arguments, if you want, are going to be assigned to the properties. So I'm going to put here, and you have this hint name, Tesla, then we put a comma. So we have again the hint, which is very helpful. So for the model we put displayed, and then for the color we put red, and for the number of doors 4. Alright, so now this is more concise, and now this is doing the exact thing that we did previously, but this is more concise, and we're using the constructor to pass those values to the parameters that we define here, and then those parameters are going to be assigned to the properties, respectively those properties, name, model, color, and doors. You're going to see what is the difference between the properties and parameters in the next video. Now, we have also an error here because this also expects some values to its constructor. So instead of putting those values here, we put up here Ford, Mustang, blue, and 2. Now we can delete this because we already passed the values for this second object for its properties. And now if you look at the code, the code is more concise and more and easier to read. Now if you run this code, you will have the same output because the code works well. So now if you look at the console, let's decrease this a little bit. Let's scroll up. You have the name Tesla, model is placed, color red, doors 4, the car Tesla is moving, the car Tesla has stopped. So we have the same output as previously. And down for the second object we have the name Ford, the model Mustang, the color blue, doors 2, and the car 4 is moving and the car 4 has stopped. So our code works well. Now let's close the console. But if you go down here, you will see that you have this the properties color. So if you hover over them, it says the property is explicitly assigned to a parameter name, so it can be declared directly in constructor. Now what is saying here in other words is that we can put the properties directly in the constructor, so you don't need to define the properties down here and then assign the value that is passed to the parameter to the property. And the difference between the properties and parameters is that the properties, respectively those that we define in the header of the class inside the parentheses here of in the constructor, is that the properties are not storing the state of the class. They are not storing the state of the object. They are only here to get whatever value we pass here. So whatever value you pass here, and its job is to only get that value and assign it to the property name. So only the variables which are declared inside the class are storing ultimately the state of that object. So if I delete, let's say if I delete this here, now we have an error here because the property name it says on unresolved reference name, create member property card.name, and that is because the property name is not declared. It's not exist. It's not a characteristic of a car. We didn't define property name because here the parameter name is only there to get the value and then pass the value to the property. But we can let's press Ctrl Z to put the code back. Now the error disappeared because we have the property declared, but because the only thing that we do here is to get the value that is passed to the property as an argument here and for the next ones, and then assign it to the property, we can put those directly in the constructor. So to do that, we can hover over here and let's hover over and click on this light bulb and click move to constructor. So now you have the same thing, but the only difference is that you have this var keyword in front, and that is responsible for changing the parameter into a property. So let's do the same thing for the next ones. Move to constructor, and now we don't have that error that we don't have a property for our class because they have the var. So if you put the var or the var keyword before declaring the parameter, it is going to be converted into a property. So now those are properties of our class car. So they are storing the value that we pass to them for the object that we create. So it's not like previously where we have the property, the parameter, and then the value is passed to the property inside the class. So now if you run this code, we have the exact same output. The only difference now is that this is more concise. We have the properties declared directly in the constructor, so we don't have declared the parameters and then we assign the value that is passed to those parameters to the properties. So you can declare the constructor like this if you want. So the question may arise when to use properties and when to use parameters. And to answer that question, you need to have in mind that if you want to do some work before you assign the value to the property, because in our case the value that is passed here to the property in this case is directly stored in the property, so we cannot add some validation to check to see if I don't know if this name is if it starts with a specific letter or if it's an uppercase, or because the value that is passed as an argument to the property there I say property because they are now declared as properties, is directly stored as the state of the object. So if you want to do some work before you assign the value of the property, you need to declare it. Let's say that you want to, let's actually delete this, and I'm gonna declare it as a parameter. So let's say that you want to trim the space that is passed. So let's say that I put some spaces here. Let's actually press Ctrl Z to see what is happening if I don't do that. Alright, I pressed Ctrl Z too many times. So let's again let's put some spaces here. So now if you run this code, let's run it again. Now, because the value that is passed as an argument here to the object car1 is passed directly to the property, so it's stored in the property, and we don't do nothing with it. We have also the space, but if you want to delete that space, currently we can do that because the values pass directly to the property, and there is nothing that we can do from that point. And to change that, we can declare the property that is defined here, the property name, as a parameter first, and we can declare it down here. We can declare down here now the property, and we can put equals, and now we pass the parameter to the property, so we assign name here. But before that value is assigned to the property name, we put dot trim, and that is gonna remove the spaces. So dot trim is a function which is part of the string class, because all the data types that we looked at are also classes. So you can call functions on them the way we called functions on our objects. So name.trim removes the space. So in this case, it removes the space that we have here. And after that, it's assigning the value to the name property. So now if you run this code, now we have the space, but if you run the code, so let's go up, run the code. Now, as you can see, the space is removed because we pass the value to the parameter now name. Then the parameter name trims that space, and after that it's assigned the value to the property name. So in this case, this can be a scenario where you can declare instead of declaring directly here the property, you can declare it as a parameter. But what we can do if you want to add more code than just one line of code. In that case, we will need to use what is called initializer blocks. But we're going to look at the initializer blocks and at other things in the next video, because this video is long enough. So see you in the next video. So in the last video, we looked at constructors and how you can use constructors to construct your objects, and it was an alternative to defining the values to the properties of a particular object. And we've also looked at how you can define this was, I should say, it's also called the primary constructor that we have here, the parentheses and then the parameters or the properties. And we've also talked about how we can define parameters to our constructor, and then how we can convert those parameters directly into properties. And I also talked a little bit about how and when to use parameters and properties. But in this video, we're going to continue our discussion about parameters and properties, and specifically going to look at how we can execute more than one line of code when the object is created. Because now when the object is created, and in the last video we trimmed this space that we have here, Here you can execute only this line of code. So if you want to add more line of codes here to do some to do a more complex validation, we can't, because here we can put just one line of code. And to add more than one line of code, we need to use what is called initializer blocks. And initializer blocks are, as you'll see, some blocks where we can put our code. And you can put more than one lines of code. You can put as many lines of code you want, and that code is going to be executed when an object is created, when an instance of your class is going to be created. So this is what we're going to do in this video. Also, I should say that you can declare the class in another file, not just in this file like we did here. So we can open now the project pane. You can go to src, go to main, go to Kotlin, and here on Kotlin you can right click, select Kotlin class file, and from here make sure to select file, and I'm gonna call this file classes, because here we're gonna put our classes. Respectively, we're gonna put our car class, but you can put more classes there. And we're just gonna copy this class that we define here, Control C, and paste it here. Now I have an error because this is declared 2 times, here and here, and we just delete it from here. And now the error disappears. And if you run this code, we get the same output, because our code works perfectly well now. The only difference is that now we put our class in a different file, and my suggestion for you is to put the class, if you want, in a different file, because in this way you have the code in a more organized way, because here you have your class, here you have the code, the objects that you create with that class, and so on. Now, for this video, I'm gonna create a different class, and to do that, I'm gonna declare another class, but I'm gonna declare it down here, and I'm gonna delete the code that we have here, because we're gonna use a different class, and the class is gonna be called user. So it's gonna represent the end user object. So we type here class user. Now we create the constructor, the primary constructor. We put parentheses. We define the parameters or the properties. For now, I'm gonna define directly the properties here. So we type here the var or the var keyword to have the property declared. Var name string. So it's gonna be stores text. Var last name also string, and var age, this is gonna be an integer. So with this class, we're gonna create some user objects. We're gonna put curly braces, and for now we're not gonna put any code here. So let's create an user. So let's type here val. Let's call it user. You can give it whatever name you want. So let's create a new object now. So we type here user, and then we put a parenthesis, because we're gonna pass the values to the constructor here. So we need to pass a name. I'm gonna type Alex, last name Dobinka, and for the age 23. So now we created a new instance, a new object using the class that we define below. But what if I want to pass to the name property only the names which starts with the letter A? In that case, we need to declare this property as a parameter. First, we need to declare here the parameter, and then to declare the property below. And before we assign the value that is passed to the property, we need to do some validation. And if that argument that is passed to the parameter is starting with a letter, then we're gonna assign the value to the property name. Otherwise we don't do that. So to do that we need to use initializer blocks, because we're gonna type more than one line of code. And the initializer blocks are used in conjunction with the primary constructor. So when we create a new object, like we did here, the initializer blocks or the initializer block is going to be called immediately when the object is created. And to use an initializer block, but first let's declare, let's change this to a parameter. So let's delete the var keyword in front of the variable. So now we have only a parameter here. Now let's declare the property down here. And now here we need to define an explicit type declaration. So we need to put here the type string, because as I said, we're not gonna assign the value to the property directly here in one line of code. We're gonna assign the value to the property inside the initializer block after we do the validation, respectively after we check to see if the name that is passed to the objects that we're going to create with the class starts with the letter A, and if the argument doesn't start with the letter A, then we're going to assign an empty string and we're going to output something to the console. So this is why we need to provide here the type, because we're not going to assign the value directly here, so it cannot infer what kind of data is going to store. Then we press enter, we type init, and here we have a suggestion. We have the init keyword and then we have the curly braces. Press enter, and now here we're gonna add our validation, and here we type if parentheses. Now we type name. So now we're referring the name parameter defined above here. So if name, or the value that is passed to the name parameter, first we're gonna lowercase that name, and to do that we type here name dot lowercase, because I want to have both cases. So if the user passes let's say a name with a lowercase letter, then we're gonna check to see if it starts with A. But if the user passes the name with an uppercase letter, we also want to check to see if that letter starts with A. And to cover both cases, we lowercase the input. We lowercase the name, so we lowercase all the letters. Then we put here another dot, starts with, and we put here A. And if that is true, then we're gonna assign whatever value was passed to the name parameter to the name property. And we cannot type here name equals name, because now it's referring the parameter here. And to refer the property that we define here, we need to use what is called the this keyword. So the this keyword is used to refer the properties of the class. So we type here this, so we're saying this name. So now we have this name, and we have we have this v variable here. Then we put equals name. So now we assign the value that is passed to parameter only if that value passed to the parameter starts with the letter A. Then we're gonna assign the name to the property name. Else, if that is not true, put curly braces. And now we need to cover the else part, because if this is not true, we also need to pass a value to the name property. The name property cannot stay without a value, so we need to pass also a value here. Else, we're gonna put this dot name, and we're gonna put user. So I'm gonna put the user text if the name doesn't start with the letter A. And we're gonna also output some text to the console. So we put println here, and we type the name doesn't start with the letter A or capital A. So now if you create a new object here, so we type here val, let's say friend, we create a new object, so we type user. Now we need to pass the values to the constructor, so we put here let's say John, let's put Smith, and let's put 30. Now, because the value that you pass here to the parameter name doesn't start with a letter A and start with the letter J, this validation inside the initializer block is gonna be false, and then it's gonna execute the else part, and it's gonna assign to the property name the user text, and it's gonna output the name doesn't start with the letter A or A. But if that is not, if it's true, if it starts with the letter A, then this line of code is gonna be executed, the if part, and it's gonna be assigned. It's gonna assign the value to the property. So now if you run this code, we get the name doesn't start with the letter A or A, and it's correct. Our name starts with the letter J. So if I put here, let's say Andra, let's change this to let's say also Smith. Now if I run this, now we have no output because the initializer block is called, and the if part is evaluates to true, and it's assigning the name Andra to our name property. So let's add the print element down here to see that is correct. So let's print the value of the property name for our friend object, and we put here and here we type $, we put curly braces, and we type friend dot name. So now if you run this, let's close. Get name Andra. Let's put comma here. Let's put colon here. So our initializer block is called, the code inside the initializer block is executed, and then this if check evaluates to true, and then it assigns the name Andra to our property name. But if I put here John, let's type it like this, let's say, to see that it's working, because we lowercase the letters. We get the name doesn't start with the letter A or A, name user. So the initializer block is executed immediately when the object is created, and the code inside the initializer block is called. It checks to see if it starts with the letter A, and if not, then it is assigned to the property name user. So we have this is why we have user here, and then it outputs this text to the console. So this is how we can use the initializer blocks in conjunction with the primary constructor, and you can also put more initializer blocks, and the order in which you put the initializer blocks matters, in the sense that the order in which you define the initializer block is going to be the order in which they are executed. So the order in which you define them is important, but most of the time I think you use only one initializer block to put your code. So this is our discussion about initializer blocks, and in the next video we're going to look at because we talked about the primary constructors, there is another type of constructor which is called the secondary constructor, or the secondary constructors, and we're going to also look at the default parameters, because we can define default values to the properties or to the parameters of the constructor. So we're gonna do that. We're gonna do that in the next video. I'm gonna end this video now. So now it's time to start a discussion about secondary constructors, because besides our primary constructor that we define and that we talked about, in Kotlin we can define multiple constructors, and those are called secondary constructors. Now you may be wondering why you will need secondary constructors. And to answer that question, we need to consider the user class and the user object that we can create. So let's say that a user only provides its first name, and for the properties last name and age doesn't provide any value. In that case, you'll need a way to define some default values for those properties in case the user only provides the first name. And if let's say the next user does provide the first name and the last name and the age, in that case you're gonna use the primary constructor. But if it doesn't provide those values, then you're gonna use the secondary constructor. But to make this more clear, let's add the code, and we talk about while I am writing the code. So let's delete the initializer blocks that we have here because we don't need this code. And let's also put the property now. Let's define the property in the primary constructor. So let's just put here a var, the var keyword in front of the variable. Let's also delete this println. And let's delete the values here for the last name and the age. So now, as you can see, we have an error because it's expecting here it's expecting an argument, a value for the last name and for the age. And to solve that problem, we just go down here and we type constructor. So this is the keyword for declaring the secondary constructor. And we press enter to fill in that for us, and we put parentheses. And now, here in the parentheses, we define the parameters. And I am specifically saying parameters because, as you will see, the secondary constructors cannot declare properties. They can only declare parameters because, anyway, let's define here the parameter. So I'm gonna type here name. Let's put here the type of this variable is going to be a string. Now, if you hover over here, it says primary constructor call expected, insert this call. So what all the secondary constructors need to do is they need to call the primary constructor, because ultimately the primary constructor is the one which declares the properties for the class and stores the values of that property. And to do that, we put here colon, we type this, so we put colon, this, type the this keyword, then we put parentheses, and to the this call we pass the name, so this name that we define here, and for the next two values we're gonna pass some default values. So here I'm gonna put user because let's say that because as I said in the beginning, this user is not gonna provide the last name. So let's put here last name, not user, last name. And for the age, let's say 0. All right. Now, what this is gonna do is, now if you look up here, you don't have an error. So let's so now we don't have that error because now it's using the secondary constructor, is passing the value here Alex to the secondary constructor that we define here, and here we define only the parameter, and the value that is passed to this parameter then it's passed to the primary constructor, because by putting colon and this and parentheses, we're calling now the primary constructor. And is the primary constructor the one which ultimately declares the property and stores whatever value we send to him. In this case, we send the value Alex, and for the last name we just send the text last name, and for the age we put 0, because this is our way to saying that this user doesn't want to provide its age. So this is why you need to call the primary constructor from the secondary constructor, because again, the primary constructor is the one which ultimately declares the properties of the class, is the one which stores the properties of the class. The secondary constructor only only takes parameters and then calls the primary constructor. So in fact, if you put here the var keyword, you have an error which says var on secondary constructor parameter is not allowed. That is because the secondary constructor cannot declare properties, only the primary constructor. And because, as I said, we can declare multiple secondary constructors, we can type here constructor, so we can declare another secondary constructor, and here we can put name, here we put string, then we type last name, also a string. So this secondary constructor is only gonna take the name and the last name as arguments. The age is not gonna, this secondary constructor is not gonna take any value for the age. Now we need to put colon. We type this parenthesis because now we're calling the primary constructor, and here we pass the name that is passed to this secondary constructor, this that we define here, the last name, and for the age we're gonna put 0 because this secondary constructor doesn't take any value, any arguments for its age. But because, as I said, ultimately the primary constructor is the one which defines the properties, we cannot call the primary constructor and not pass any value. So we pass this default value here, and so now if you go up here and let's say that I delete the age, now our code works fine, because now what is happening here is this the value for the name and the last name is passed to this secondary constructor, this one here, and the secondary constructor then calls this primary constructor and it's passing the two values to the primary constructor, name, respectively this name, John, and last name, Smith, and for the age it passes the default value 0. So this is why we can pass here this is why you can avoid here to pass let's say you can avoid to pass the last name and the age for the first, because here is using the first secondary constructor, and this object that we created here, it's using this secondary constructor, because here we're passing only the first name for the a value for the first name property and a value for the last name property. So it's passing them to this secondary constructor, which then in turn calls the primary constructor. It passes them to the primary constructor, so it passes the values for the two properties, and the last one is defaulted because you don't provide the value for the age. With secondary constructors, you can also at the end of the call of the primary constructor, you can put curly braces to have some code executed when you create an object with that specific secondary constructor. So you can put here curly braces, and inside the curly braces you can have some code which is going to be executed when you create an object with this, let's say, secondary constructor, when you create an object with this secondary constructor. So it's up to you what code you put there. But to illustrate this, let's put a println statement here in this secondary constructor. So let's type here println, and here I'm going to type second, and I'm going to type second because this is the first constructor, this is the primary constructor, and this is the one which ultimately does all the work, is the one which stores the value for the properties, and this is the third constructor. So let's copy this, let's put here third, just for illustration. Also, let's output in the console the value of the property values for these objects. So let's type here println, and let's type here name equals, let's put $sign, let's put curly braces, let's use our user variable, Now let's call the properties on this object. So let's type name. Now let's press Ctrl D 2 times, and let's put here now last name and age, and let's also add a space between the information about the two objects to make things more clear. So let's put a println here, let's put a backslash n here, and let's copy the code that we have here. Let's paste it below. Let's change this object to our friend object that we created. So let's type here friend, and I'm gonna speed this now a little bit because it will take some. Now let's output this information in the console. So now what we have is we have second and then third, because this first object is using the second constructor. So this is why we have here second, and then the next line of code is called, and we have third because this object that we have here, the friend object, it's using the third constructor, this secondary constructor. So this is why we have here third. Then we have the values for the properties then we have the values for the properties of the user object. So we have here the output down here, and then we scroll down and we have name John, last name Smith, age 0, because we have the property values for the second object, for this object, and this is okay, this works completely fine. The thing to have in mind is that now we're using the secondary constructors, and the secondary constructor then calls the primary constructor, and the primary constructor is the one which ultimately stores the values, which ultimately declares the properties and stores the values. But one thing to notice in the output is that the first object has the name Alex, and the last name, and the age 0. That is because the first object is only taking a value for the first name property, or for the name property, and for the last name and the age, because it's using this secondary constructor, is only passing the first name, which is Alex, that we have here, and then it's using the default values, last name and 0. It's passing those default values to the primary constructor. So it's calling the primary constructor, it's passing the value Alex, and then the default value last name and 0. This is why I have last name and 0 here. And for the next one, we have name John and last name Smith. This is because now this is using the next secondary constructor, and that takes as arguments the name and the last name, and then it's calling the primary constructor. It passes the first name and the last name, and the age is defaulted, so we have 0. So this is why we have here John and Smith and then 0. So it's important to notice this and to think about how this thing. So this is our discussion about multiple constructors, respectively about secondary constructors. In this video you saw how we can pass a different number of values to our properties. Ultimately you pass all the values to the properties by calling the primary constructor and providing default values, because in this way you can satisfy all the possible cases. So if in our case one user only provides the name and the last name is not provided and the age, is going to use this secondary constructor and is going to pass the last name as default and the age 0. And this is in a way similar to overloading functions, but is not the same, because what we're doing here is overloading the constructors. And in this way you can think about why we are overloading the constructors, and that is because if we didn't have secondary constructors, we would have to create another class with a different number of parameters, or the different number of properties, and we will need to create each object with that specific class. Let's say that we create this object which only takes a value for its parameter name. Then we have to create a class in which we're gonna define only the name property, and then we're gonna create that object only with that class. And if an object, let's say if a user creates, if a user doesn't is providing the name and the last name but not the age, you will have to create another class with only the name and the last name defined as its properties. And you can see that this will generate duplicated code and so on. And we can solve all of this by using secondary constructors and calling the primary constructor. So see you on the next video. And because Kotlin is about conciseness, in the next video we're going to look at how we can do the same thing that we have here with default parameters, because Kotlin supports for its properties, for its parameters in the constructor, default values. So the same thing that we have here can be achieved by providing default values to the properties. So see you in the next video. So now it's time to look at default values for our properties. And first, let's delete the secondary constructors. And now we have errors here because it expects the value, it's expecting the values for the next properties here. And let's also change this to first name, because I refer to it to the first name, but it was called, it is called name, so let's call it first name. So go right click on it, go to rename and then to refactor to change it in all the places, and let's call it first name. And as you can see now it's changed it in all the places, then press enter. So now we have the first name. And default properties are default values to our properties are basically, they are similar to default values that we provide to our parameters when we talked about functions. And what we do is, let's say that I wanted to provide a default value for the last name, we just put equals. So inside the primary constructor we put equals, and here we put, let's say, last name. So now this has the last name as its default value if a value is not provided for the last name. And here you can put also equals, and we put 0. And now the error, as you can see, disappeared from both of our objects, because now what it's doing is when we don't provide a value for the last name and for the age, then the default values that we provide here are gonna be used as the values for the properties. So this is a way of achieving the same thing that we achieved previously with the secondary constructor, but this is more concise. And the question is when to use one or the other. Is the answer may be if you want to execute some code when an object is created, let's say with one of the, let's say if you want to execute some code when you create an object, then you can use secondary constructors, because as I said, secondary constructors can have a block of code when which can be executed, but the default, because primary constructor don't have a block of code, we cannot do that. Maybe you could use initializer blocks, but that is open to discussion. So this is how you can provide default values to the primary constructor. And our code works fine, and it's very concise, very beautiful. And the next thing that you can do is that you can also use named arguments. So you can use because here you use the first name and the last name. And if I because those are both strings here, you cannot see the distinction. But if I put here now I can use the name argument, so I can put here first name, equals. So it's similar to the way we have name arguments in our function, and here you can put the text John also here. And this with this thing you can change the order in which you need to define the values for the parameter. So let's put here last name. But to illustrate this better, let's create another object. Let's type val user2. Let's type user, and let's put here Ioana. But let's use the name argument. So let's put first the age. So we're gonna provide the value for the age. Let's say 19, and let's type first name. So here let's put Ioana, because this is a string in quotation marks. And for the last name, let's say let's type also the name argument, last name. And for the last name, let's put here Dobby, let's say. Right? So what we did here is that in the primary constructor, the order of the property is very specific. We have the first name and the last name, and then we have the age. But with the name arguments, we first provided the age. So we provided a value for the age property, which is the last one. So, and then you provide a value for the first name. And with name arguments, similar to the way used in our functions, you can pass the values to the properties in which order you want, irrespective of the order in which they are defined here. So this is very powerful, if you ask me. It's very interesting because you can pass the values to the properties irrespective of the order in which they are defined. So this is our discussion about default parameters and named arguments with the primary constructor. And you cannot use default parameters and name arguments with the secondary constructors. They can only be used with the primary constructor. So see you in the next video. But before I end the video, let's actually run this code to see that it works in the same way it was working in previously when we used the secondary constructors. So let's run this code. So you have name Alex, last name, because it's using this default value that defined here. Then we have age 0 because it's using this value defined here. So this object. And then we have name John, last name Smith, age 0 because now it's using this default value. So the same thing can be achieved using default parameters. And we didn't output the values for the third object that we created here, user2, but you can do that as a challenge. If you want, you can output the values for this object. So see you in the next video. So now it's time to start a discussion about getters and setters, because so far in our videos, even though we didn't see explicitly the getters and setters here, we've used the getters and setters every time we got the value of a property and every time we assign a new value to a property. And the getter and setter in Kotlin are implicit, so they are declared, they are auto-generated by default by Kotlin for you. So every time let's say you get the value of an object, let's say that you get the value of the user, that first name, what actually happens here is not that we're getting the value of the first name directly, even though if you look at the code, this is what it seems to be. What is happening is that every time we get the value of a property, that value is returned by the getter. So you never access the property directly, and you never thus change the property of the value of a property directly. Every time you are using the getters and setters. And now this discussion is touching on a very important concept in Kotlin programming, and that is encapsulation. So encapsulation basically means to protect, to hide the inner workings of the class from being accessed outside. And if you look at this syntax that we have here, it seems that we actually accessing the values, the properties directly, but as I said, that is not the case because we always using the getter and the setter. And because we always use the getters and the setters, the getter to get the value and the set to change the value of a property, that means that your data, your properties are never accessed directly. Thus, the laws of encapsulation are not broken. In other words, you never allow somebody outside of the class to access directly that property. So this is why we have getters and setters, and this is why the getters and setters in Kotlin are implicit. So they are not even declared explicitly here. We don't see any code which will imply that we have a getter, a setter here, because they are automatically and by default generated every time you define a property. So every time you define a property, either in the primary constructor or inside the class, the getters and the getter and setter is automatically generated for you. But let's say that you want to override the getter and setter to provide some additional code to the code that is by default provided. You can do that by changing, let's say, this property to a parameter, and to override the getter in setter and to see how the getters and setters actually look under the covers. Just type here var. We define the property first name. We assign the first name parameter to property. Now the getters and setter need to be overridden immediately after we define the property. So we cannot have some code here and then to override the getter and setter. So we need to define them immediately after we define the property. So we type here get, and as I'm typing, you see that I have some suggestions. Then you go down here and you can choose this one. So you have parentheses, curly braces, and inside the curly braces you press enter. Here you type return field. I'm gonna explain immediately what is this. And now we need to override the setter, and to do that we just type set, and I have some suggestions. We also go down here, we choose this one, press enter, and here we type field again, this identifier, and we put equals to value. So this is the implicit code that is generated, that is auto-generated by Kotlin for you every time you define a property in your class, either in the, as I said, in the primary constructor or inside the class. So because in fact, if you look here, we have some underlines, and if you hover over here, it says redundant getter, remove redundant getter, because and also for the setter, redundant setter, because they are redundant because they are implicitly again auto-generated by Kotlin for you. So this code is redundant here. You don't need this code because Kotlin already provides this code under the covers for you. But if you're not satisfied with this code, with this implicit code that is auto-generated by Kotlin, you can override them like we did here and provide some additional code. So we can put here, let's say, some text, so that every time we get the value of our first name property, we're gonna have a prefix, and let's put here first name. Let's put a colon, $, and field. I'm gonna explain immediately what this field is, but let's say first how this works. And here let's put a println to print the value that is passed to the setter and then assigned to the first name property. So let's put here $, value was assigned to first. So now if you run this code, Now we have name, so we have our text that we have here, name, and then have first name Alex. Let's actually delete this text to make things more clear. Let's delete this text. Let's delete this. Now let's run this code again. So what we have now is that every time we get the value of our property name, we have that prefix first name that we have overwritten here in the getter. So the getter is called, as I said, the value is returned by the getter. So the getter is called, it returns the value of the first name property. So this field is the first name property, but it has this identifier field because of an important reason, which I'm going to explain immediately. So it returns the value of the first name property with the prefix first name, and we have first name, the text that we have here. Then we have the value of the first name property. We have Alex in our case because our object has the name Alex, as the property name Alex. Then for the setter, we don't have any code here. Also, we have the first name prefix for John. So our code, every time we get the first name property by any of our objects created by using the user class. It gets that value, it returns that value through the getter. And the setter, we don't have value as assigned to first name property because the setter is called only when we change the value of a property. And to do that, we type user, like we did in our first video about object-oriented programming, dot first name equals, let's say, let's put here Vlad. So now if I run this code, now the setter is going to be called because the setter is called, as I said, only when we change the value of our property. So we get Vlad was assigned to first name property. So the code inside the setter was called because this code that we type here is calling the setter. So our code always goes to the setter. And the code that we have here, user.first name Vlad, what it's actually doing is passing that value Vlad to here. So this parameter that we have here is receiving the value of Vlad, and then that value is assigned to first name property. Again, we have this field identifier for a reason, and the reason is going to be explained immediately. So the getters and setters are working well, and they are, as I said again, the use always when we get or we assign a new value to our properties. Now, what is this field identifier? Why I didn't type here first name, and here I didn't put first name equals to value. So whatever value is passed to the setter, then that value is assigned to the first name property. So why we don't do that? And the reason for that is that because this syntax user.first name equals Vlad is calling the setter. If we put here first name equals value, so first name equals Alex, it will be equivalent to call the setter again. So this line of code that we have here, it will call the setter again, it will pass the value to the setter, and then it will assign the value again to the first name. So it will call the setter inside the setter forever. It will generate an error. And to avoid that recursive call, that infinite call, we need to use this field identifier. So the field in the identifier is the first name property, but it has this special use that it bypasses that error that it will be generated if you use the first name here. So in fact, let's put here first name to see. So if you put here first name instead of field, and we have an error here, let's put here field, because I want the error from the setter to get in the console, not the error from this thing here. So now if you run this code, as I said, that will generate a recursive call. It will call the getter over and over. So we get the error. So you see we have Vlad was assigned to first name property, Vlad was assigned to first name property, Vlad, and so on. That is because the setter, it's calling the setter forever. It's a recursive call, because this line of code here, it's calling the setter, it's assigning the value to the, sending the value to the setter, then it's that value is assigned again to the first name property, which in turn calls again the setter, and so on. So this field identifier is used because it has this characteristic of bypassing that error. This is why we're using the field instead of the first name property here. And it's basically the first name property, but it has this specific characteristics which bypasses the recursive call which we got when we've used the first name property. Now if you run the code, now I have no error because the recursive call is not happening, because we're using the field which bypasses that error. So this is why we're using and Kotlin has this thing field, and the field can only be used inside the getter or the setter, not anywhere else outside the getter or the setter. And the same is true about the getter. This is why you need to use the field identifier inside the getter also, because it will generate a recursive call again. Now, to illustrate better, because you maybe find confusing this discussion about getters and setters, what they really are. They are equivalent to having two functions which update the first name property and return the first name property. So they are equivalent to having a function called set first name, and this function defines a parameter called, let's call it new value. It's gonna be of type string. Let's put curly braces, and here we type this dot first name equals new value. And the getter is equivalent to having a function called get first name, and this is not going to take any parameter. We're going to say explicitly here that it's going to return a string, because it's going to only return a value, and this is going to return the first name property. So we put here this dot first name. So the getter and setter that we have here are similar. This is illustrative for you to have in mind, to having two functions which are setting the first name property, or updating the first name property,